Hello and welcome to this video on the life cycle of stars. If you have ever looked up at the night sky and wondered what makes those twinkling points of light shine so brightly, you are in the right place. Today, we are going to take a journey through the life of a star, from its birth in a cloud of gas and dust to its eventual death as a white dwarf, neutron star, or black hole. Let's start at the beginning. Stars begin their lives as clouds of gas and dust called nebulae. These clouds are made up of elements like hydrogen and helium, and when they become dense enough, gravity takes over and the cloud begins to collapse. As it does, it heats up and becomes denser, eventually reaching a point where the center of the cloud is hot and dense enough to trigger nuclear fusion. Nuclear fusion is the process in which two atomic nuclei combine to form a heavier nucleus. In the case of stars, this involves the fusion of hydrogen atoms into helium. When this reaction occurs, a tremendous amount of energy is released in the form of light and heat, and this is what causes a star to shine. Make sure to like and subscribe to know more on stars. Next episode will be on how to classify the stars. As the star continues to burn hydrogen in its core, it enters the main sequence stage of its life cycle. This is the stage at which the star has achieved a stable state, with the energy released by nuclear fusion balancing the force of gravity pulling the star inward. The length of time a star spends in the main sequence stage depends on its mass. Smaller stars, such as red dwarfs, can spend trillions of years in this stage, while larger stars may only spend a few million. But what happens when a star runs out of hydrogen fuel? This is where things get really interesting. As the core of the star begins to contract and heat up, the outer layers of the star expand and cool. This marks the beginning of the red giant phase, during which time the star may become many times larger than it was in the main sequence stage. Eventually, the star will begin to run out of fuel in the outer layers of its core, at which point it will undergo a series of contractions and expansions. This marks the beginning of the planetary nebula phase, during which the outer layers of the star are ejected into space, forming a cloud of gas and dust known as a planetary nebula. The remaining core of the star, which is now a white dwarf, will continue to shine for billions of years before eventually cooling off completely. But what about stars that are more massive than the Sun? These stars will still go through the protostar, main sequence, and red giant phases, but they will eventually run out of fuel in their cores and begin to fuse heavier elements. This process will cause the core of the star to contract and heat up even more until the temperature is high enough to trigger a new round of nuclear fusion. This marks the beginning of the supernova phase. During the supernova phase, the star will undergo a catastrophic explosion, releasing an enormous amount of energy and creating a bright flash of light that can be seen from billions of light years away. The remains of the supernova explosion can take on two forms. If the original star was less than 8 times the mass of the Sun, it will leave behind a dense core known as a neutron star. If the original star was more than 8 times the mass of the Sun, it will leave behind a black hole. The life cycle of stars is a complex and fascinating process that spans billions of years. From the birth of a star in a cloud of gas and dust to its eventual death as a white dwarf, neutron star, or black hole, stars are constantly changing and evolving. The elements that make up our bodies and the world around us were created in the hearts of stars, and the light that we see in the night sky is a testament to their enduring beauty and power. But why is the study of stars and their life cycle so important? Well, stars are the engines of the universe, creating and recycling the building blocks of life. When stars explode in supernovas, they release heavy elements such as iron and gold into space, which can eventually become part of new stars and planets. In fact, our own solar system is thought to have formed from the remnants of ancient supernovas. Studying the life cycle of stars also helps us to understand the origins of the universe itself. When the universe was born in the Big Bang, it was made up almost entirely of hydrogen and helium. All of the other elements that we see around us today, from carbon and oxygen to gold and platinum, were created in the hearts of stars. By studying the life cycle of stars, we can better understand how the universe has evolved over billions of years. Make sure to like this video. Subscribe to learn about the classification of stars. From the birth of a star in a cloud of gas and dust to its eventual death as a white dwarf, neutron star, or black hole, stars are constantly changing and evolving, shaping the universe around them in ways that we are only just beginning to understand. Thank you for watching, and be sure to subscribe